now let us look into this concept of non-decreasing and non-increasing subsequences. So yeah, going to the whiteboard, let us see by definition what is non-decreasing and non-increasing subsequences. So a sequence or an array is said to be non-decreasing sequence if the following condition holds, right? So let us say that you have this array, right? Let us say that you have this array with elements a1, a2, a3, so on, ai up to a. Now this array a is said to be in non-decreasing sequence if the following condition holds, that is, for any two consecutive numbers in this array a of I minus 1 should be strictly less than or equals to a of I. So if this condition holds, where I goes from 2 to n, right? So if this condition holds for all the consecutive elements in the array, let's say a, then this array is said to be in non-decreasing sequence. Is said to be following non-decreasing sequence. So okay, let me write it over here. Non-decreasing, right? Now similarly, opposite thing is non-increasing one. So here the condition will be for non-increasing. The condition would be this: a of I minus 1 should be greater than or equal to a of I. For again I varying from 2 to n, right? So if this condition holds on the above array, then it is said to be non-increasing sequence, right? So okay, let us take the example as well. So for non-decreasing one, let us take this example for non-decreasing sequence. So let us assume this array a as 6, 6, 7, 8, 9, 10, 11, 11, 12, right? So if you pick up this array, right, and if you pick any two consecutive elements, you'll see that the condition that we talked about in the previous slide will hold, right? So if you pick up any two element, a of I minus 1 will be always less than or equals to a of I. So this array is in the non-decreasing sequence mode. So again, let us pick up this example: 6, 6, 7, let us say 6 again, 8, 9, 10. So this one is not in the non-decreasing sequence, because here we have this 7 and 6 which is not following this condition. So this one is in this one is not following the non-decreasing sequence rule, right? And similarly, we can also pick up the example for non-increasing one. So let us pick up this array B, and here let us say that 10, 10, 9, 8, 8, 7. So here a of I minus 1 is strictly greater than or equal to a of I for any two consecutive numbers in this array, right? If you pick up any of these two consecutive numbers in the array, you will see that this condition is holding. So this is a non-increasing sequence, right? So I hope this concept is clear: what is non-decreasing sequence, what is non-increasing sequence. And then again, I want to discuss one more thing, which is suffix. So let us talk about this as well: suffix of length n. So for example, let us say that you have this again array A, the same one, right? 6, 7, 8, 9, 10, something like this. Now let's say you want to find the suffix. You want to find the suffix of size 3, right, in this array A. Then what is suffix? So suffix of size, let's say n, in an array is nothing but the last n elements in the array. So in our case, suffix of size 3, right? So this one is 10. So suffix of size 3 in this array A would be nothing but the last 3 elements, which is 8, 9 and 10. So this is the definition of suffix of size n in an array. So I hope these three things are clear. What is non-decreasing sequence, what is non-increasing sequence, and what is suffix of size and in an array. So now let us try to solve a very simple problem based on these three concepts: non-decreasing sequences, non-increasing sequences, and the suffix of size and in an array. So here we go. So so here in this problem statement we are given two arrays A and B of size and m respectively, and here the condition is that bi varies from pi, which means the elements in the array B varies from 1 to n for each I, which varies from 1 to m. So m is the size of the array B, and within the array B the elements are, each element will only vary from 1 to n. Now again, the problem statement is that we want to sort the suffixes of length bi in the array A in non-decreasing order. So again, let us be clear, we want to sort the suffixes of length bi and that too in the array A in non-decreasing order. So we know what is suffixes of length n. So again, we will know what is suffix of length bi based on our definition, and we also know what is non-decreasing order or non-decreasing sequence. And so this is what we want, sorting the suffixes of length bi in the array A in non-decreasing order, and what we want to output is the resultant array A after doing all these operations. And yeah, they have given the definition for suffix of length x, which we already saw, right? And then they have given the input format and output format. So in the input format they said that there will be t test cases followed by the two integers and an m, which is the size of array A and B, and followed by the respective arrays A and B, the elements of this respective array A and B. And again they have given the output format. So let us directly jump into the sample input and sample output, and let us try to solve this problem, and how will we approach this problem. So okay, so first test case is this one. Let me write this one down here. Okay, so here the array A in this case is 2, 3, 4, 6 and 1, and B is 2. And for the second test case they have given array A as 5, 7, 12, 11, 13 and 10, and B is 1, 2 and 4. Right, so one thing that we should observe here is that they want an array A, suffixes of length bi in an array A in non-decreasing order. And as we saw, in the non-decreasing order is essentially nothing but the sorted order in the increasing way. So if I go to the whiteboard here, let me go to the whiteboard here. So we saw this, right? So this array was in the non-decreasing order, and you can see that it is nothing but the sorted array in the increasing order. So to convert an array into, suffix of an array or an array into the non-decreasing order, we can simply sort it, right? So that is the main thing that we'll use, sorting. But here comes the interesting part. Let us see this. So based on the problem statement, right? So what we are interested in doing is that we want to sort the suffixes of size, this size given in the array B in the array A. So here the first element and the only element in fact in B is 2. So what we want to do is we want to sort the suffix of size 2 in array A. So after doing that operation, the array A will be looking like this: 2, 3, 4 and 1, 6, right? So we want to sort only this part, last two, suffix of size 2 is last two element in the non-decreasing order, which is 1 and 6. Now let us come to the second example. So I think here this is not visible properly. Let me rewrite it over here. So it is 5, 7, 12, 11, 13 and 10, and B is nothing but 1, 2 and 4, right? So if you want to sort suffixes of size as per given in the array B, in the array, so here first one is 1, so we want to sort the suffix of size 1. So after doing this operation, the array A would look like same, right? 5, 7, 12, 11, 13 and 10, because we are just sorting this last element. Now again we want to apply this operation for the suffix of size 2 in the array. So we will sort the last two elements again. So 5, 7, 12, 11, 10 and 13, right? So we are sorting this two. And again the last 4 elements, so these 4, right? So 5, 7, and now we are sorting these 4, so 10, 11, 12 and 13. So this will be the final array A, right, after applying the all the 3 operations based on array B. So okay, so what will be the brute force approach for solving this problem? It will be very simple, right? We'll just iterate over the array B, which is of size m. Array B is of size m, and for each element in the array B will sort the suffix of that respective size in the array A. So now this is the brute force approach, right? In this approach, what will be the time complexity? Let us analyze that. And by the way, it is very simple. I mean, very simple to write the code for this brute force approach. What we'll simply do is we'll have a outer for loop for over the array B, which will be going from 0 to m minus 1, and the inner for loop will be doing the sorting part. So the time complexity will be highly, very little bit high. So what we'll be doing is that we'll have outer for loop which will be running m times, and the inner for loop will be doing essentially the sorting part. And in worst case, you might need to sort the entire array A m number of times. So it will be m into n into log of n, right? So n log n is the sorting time to sort the array A in the worst case. So we are assuming the most fastest sorting algorithm here, which will take n log n time, and then we'll have the m, and we need to multiply it because this is the nested loops, right? So m into n into log n. So this is the time complexity for the brute force algorithm. Now let us try to optimize this a bit further, right? We can do optimization on this further. So let us see how we can do this. So let me pick up this example itself again, which was this, where array was 5, 7, 12, 11, 13 and 10 for array A, and for array B it was 1, 2 and 4. Let me add few more numbers as well, 5 and let's say 3. Okay, so now let us try to look into the modified version of our test case. So here, so this is our array A, and here this is our array B. Now let us look into one thing, right? So here let us try to sort the suffix of size 5 in non-decreasing order. So so let us now try to write the array itself after sorting the suffix of size 5 in the non-decreasing order. So the array would look something like this, right? So 5, then 7, 10, 11, 12 and 13. So here we are sorting the suffix of size 5 in non-decreasing order, right? So this is suffix of size 5 in the array, and we are trying to sort it so that we get it in the non-decreasing order. So the crucial thing to observe here is that while sorting the suffix of size 5, right, in non-decreasing order in the array A, we are by default having the suffix of size 3, suffix of size 4, suffix of size 2 and suffix of size 1 in the non-decreasing order. So here let us see by the example. So here the suffix of size 4 is this, right? So this is the suffix of size 4. You can see that this is already in the non-decreasing order. Similarly, if you see this, right, if you see this one, suffix of size 3, again it is in non-decreasing order. If you see the suffix of size 2, right, again it is in non-decreasing order, and similarly for the suffix of size 1. So this is the crucial observation, right? So when you try to take the max element in the array B, right, the max element in the array B, and sort the array, sort the suffix of that size. So max in the array B and sort the suffix in array A of that size. What you'll get is that you'll you'll by default take care of the other suffixes. I mean, all the other suffixes will be in the non-decreasing order. So this is what we need, right? So what we need to do is to find the max in B, array B, and sort the suffix of size of that max size, right? Of that max size, I mean max number size in array. So what we need to do here is that we need to take the maximum number in the array B and sort the suffix of that size in array A. And by doing that, what will ensure that all the other suffixes will be by default in the non-decreasing order. So now let us try to measure the time complexity of this algorithm. So there are two steps here, right? One is finding the max in array B, and second is the sorting, right? Sorting the suffix of that size in the array A. So first step can be done in order of n, which is because the array B is of size n and we need to find the max element in array B, which can be done in order of n. Plus second step, in worst case, would take n log n, right? Let us say that you need to sort the entire array B, and now we need to just do one sorting operation here. So it will take n log n. So overall it will take order of m plus n log n, which is better than our brute force algorithm, right? Which took so brute force algorithm took order of m into n into log n, right? So this is the crux of it. So this is how we'll optimize the algorithm, and now we can see the coding part as well. So I have already written down the code for it, and the code is highly simple actually. So what we are doing here is that we are taking the inputs as per the specification above, right? Here the input format which was specified, we are taking the inputs, then we are finding the max here in the array B, which is highly simple. So this is a very straightforward way of finding the max in the array. And then after that, what we are doing is that we are sorting the suffix of size max, suffix which is of size max element, right, that we found in B. And after doing that, we are just printing the final result, and that is what is the final result that we want. So I hope this entire concept of non-decreasing sequence, non-increasing sequence, and suffix of size n is clear, as well as the problem that we discussed. So yeah, I hope you like this video, and if so, then please press the like button and do subscribe to the channel. Thank you.